Hassler here. I'm going to do the notes for the worksheet number 6. We're going to be introducing linear regression and mostly taking a look at scatter plots and the line of best fit. And so to start, in algebra, it feels like things can be so contrived, like forced to be perfect and to be a certain way. Oftentimes we use examples that have this perfect line where you have a constant pattern that is always occurring between your points. However, in real life, that is usually not the case. We usually end up having what is called a scattered plot. And so that's really what this graph is right here. This graph is a scatter plot. I'm going to label that scatter plot. And a scatter plot is a graph or a representation of a relationship between what we have in this case on the x-axis and the y-axis. And most of the time, it does not form a perfect line. You have dots that are going to be spread out. Okay, and so let's take a look at this first example. It says Mrs. Harrison surveyed 15 of her students to see how long they spent studying for the final exam and compared that to their score on the final exam. Use the graph to answer the following questions. So real quick, for example, I want to talk about how we would interpret this information, okay? So if I come over here and I have this point, let's say this point right here, and that means that if I spend 4 hours studying, I'm going to get about a 55% on the exam. Okay, so each point relates the amount of time somebody studied and the score that they earned. So then the question in part A says, describe the trend of the data. Is it a positive trend, a negative trend, or no trend at all? And so as I look at this data, I notice that if I were to draw a line through this data, then I would have my data moving in this upward direction. And so increasing. And when I have an increasing line, it has a positive slope. And so we can say that this trend is positive. And it is a positive trend because the data points are moving upwards, or the data points are increasing when we go from left to right. So that feels familiar to us, okay? It says find the slope of the line between the point 150 and 995. Does this slope represent the trend of the data? All right, so let's take a look. If I look at the point 150, and let's see let's pick this bright green. Okay, so 150 would be this point right here, and 995 would be this point right here. And I want to find the slope between those two lines. So it means I have to remember the slope formula. So remember the slope formula is m is for slope, y2 minus y1 divided by x2 minus x1. And you can always label these, remember, x1 is the x-coordinate of the first point, y1 is the y-coordinate of the first point, x2 is the x-coordinate of the second point, and y2 is the y-coordinate of the second point. So if I were to put that information into my slope formula, I would have 95 minus 50 divided by 9 minus 1. So I get 45 over 8. And when I divide those, I get 5.625. So then it says, does this slope represent the trend of the data? Well, my slope is positive. In fact, if I were to draw a line through these 2 points, that line would match the trend of the data. It's moving in the same direction as my data, okay? And so my answer to this would be yes. Does the slope represent the trend of the data? Yes. Both the slope and the trend are positive. And we already said that the trend was positive in part A. So yes, slope is positive. All right, so let's take a look at this next question. It says, now find the slope between 590 and 885. So let's pick those points out. 590 is this point up here that I put in red, and 885 is this other point here in red. Now, if I were just to sketch a line between those 2 points, well, just looking at it, it does not look like this line between those 2 points is going to represent the trend of the data. But let's just verify that by finding the slope. Again, that slope formula, I've got change in y, 85 minus 90, divided by change in x, 8 minus 5. So is that negative 5 over 3 or negative 1.6 repeating? Okay. Does this slope represent the trend of the data? Well, no, because the slope is negative, and we said up above in part A that the trend was positive. So they don't match, okay? So the idea is that I cannot just pick 2 random points on my trend line or I'm in my data and use those to find the slope. I need to pick a couple of points that would be representative of that data. And the 2 points that we used in part B fall on this line that really fits the data pretty well. And so we actually call that the line of best fit. All right. And so the line of best fit is a line that is a good model for the data. Couple criteria that helps make the line the best fitting line, okay? And so notice that both my blue line and my green line are moving in the same direction as that data. Notice that these lines have a similar steepness to represent that data. Notice that my points, my data points, are about half of them are above and half of them are below that line. So it kind of feels like the line is moving through the middle of this data, okay? And so those are some of the criteria that are helpful when it comes to drawing in that line of best fit. So we want to move in the same direction as the data. Same direction as the data. We want to have the same steepness as the data. Both of those things are driven by the slope, okay? And we want about half the data or half the points above the line and half the points below the line. The other thing I'm going to add here is that the line of best fit is used to make predictions. So when we get further into this, we will use the line that we come up with to predict if I spend 7 hours of studying, what could I expect my score to be? And if I spend 12 hours of studying, what could I expect my score to be? Okay. All right. So let's use this idea and come down here and do problem 2. This is the graph shows data that represents the number of species added to the list of endangered and threatened species in the United States since 1996. Complete the parts that follow. And so I want to draw in that line of best fit. All right. To the best of my ability, right? And so let's get in a pink line here just for fun. And a line of best fit should move in the same direction as the data, should have a similar steepness as the data, about half the points above, half the points below of the data. It's hard to get it perfect. Computer programs, of course, can get it perfect. I'm going to try my best here. Okay. This seems reasonable. I have about half my data points are above, half my data points are below. I'm moving in the same direction as my data. It's a negative trend or a decreasing line. I have about the right steepness. This little outlier here, an outlier would be a point that's really different from the rest. It's kind of thrown me off a little bit, to be honest. But I feel like this is a reasonable estimate. Okay, something that would not be a reasonable estimate, of course, would be if I drew a line between those 2 points. That wouldn't work out very well. If I drew a line that was where most of my points were below the line as opposed to half and half. And look, those are pretty close to each other. So it really just takes a little bit of practice to get the line of best fit. All right, so let's go and answer some questions. It says, estimate the y-intercept of your line. Well, let's see. It looks like I'm going up by 20 for each of these. And so if I were to use the line that I drew in and a reasonable amount of space is similar in distance, I would estimate my y-intercept to be about 120. It says estimate the slope of your line. So now I got to pick 2 points that are on my line. And it kind of seems like this point right here is on my line and this point right here is on my line. And it looks like that is the point 1998, comma, we'll say 61. And the other point looks like it's 2001 and 10. Now, it really depends on where the points fall on your line, but you want to pick 2 points that are on your line, and these 2 points look like they're on my line. So your slope might be a little bit different than mine, but I'm going to go ahead and set this up. I've got 61 minus 10 divided by 1998 minus 2001. So that's 51 divided by 3. So negative 3, sorry. So I get 51 divided by negative 3, which is negative 17. And that seems reasonable in that it's negative, okay? And so write a slope-intercept equation, remember, is that y equals mx plus b, right? That mx plus b. So my slope was negative 17, and my y-intercept I estimate to be about 120, okay? So we get some estimates in there. All right, let's go ahead and take a look at the back page. Here on the back page in problem 3, in your packet, or what was given in class, actually, is that the points are already plotted for you. So when you do return to class and you have your packet given to you, these points here, that is distance ran in training. That's on the x-axis versus race time in minutes, and that's on the y-axis, and these points are already plotted for you. And so what you would do is you're going to then draw the line of best fit. You're going to pick 2 points, and you're going on your line. So pick 2 points on your line to estimate your slope, okay? And then actually estimate your y-intercept. You could extend your line, or you could write a point slope equation, right? And isolate y to estimate what that y-intercept is, okay? To get that y equals mx plus b. All right, so those are things that you want to try for problem 3. Now, problem 4, it says the process of finding the perfect line of best fit is called linear regression. And, we are human, so we can't find the perfect line, but your calculator, if you have a graphing calculator, can. Different computer programs can, okay? So using a calculator, here's what the linear regression would come out to be. So you would actually type this data from the table into a special spot in your calculator, and then you would run a program that allows you to do linear regression. And when you do that, this is the piece that pops out. And so that gives you the slope intercept information, where A is actually your slope and B is the y-intercept. And so this, A is your slope, which is negative 1.36 x plus b, this is your y-intercept, 81.67, and you want to see, does that match or is that close to what you came up with in part 3? So that's what A or B asks. How does the slope compare to the one we estimated above, and how does the y-intercept compare? Okay. And then finally, in problem 5, it says Mr. Musto opened a new coffee shop. Or Ms. Musto, my apologies. She recorded the number of customers she served between opening and noon for the first 20 days of business. Her results are shown in the graph. Which line best fits the data? Well, first of all, if I were to draw in a line of best fit, something like this, it looks to me, based on my very quickly drawn line of best fit, that I have a y-intercept of 20. So it really eliminates A, and it really eliminates C. And then I want to estimate what my slope would be. And so I can pick 2 points on this line. So it kind of looks like my line goes through this here and this here, right? These are not data points on my line, but these points would be points that are actually on my line. And it kind of looks like they're going through, just the way I quickly drew it, kind of looks like they're going through my grid points, right? So it kind of looks like, careful with your scale, right? Scale of 5 here, really 2.5, and a scale of 10. So it looks like I'm going up 10. If I do rise over run, I get up 10, and then over 2 blocks, but moving over 2 blocks is really moving 5, so over 5, which would be 2. So it looks to me like B would be our best answer. Okay. All right, so your job is to give 3 a try based off our discussion with problem 2, and verify that with problem 4 to see if it lines up, and ask your teacher any questions that you might have.